In this class, we are going to start circles. So, what do we know about circles? What are circles and how they are constructed? We usually take a fixed point in the two-dimensional plane. I think it is not visible now. It is visible. Yes, we take a fixed point in the two-dimensional plane, and we try to see all the points which are at a fixed distance from this point. So if we can join all such points which are at a fixed distance from this point, then those points, by joining those points, the shape we get is called a circle. So here we are taking this point as the fixed point, and here this point as the moving point, which is keeping the distance fixed from that point. So here we can say that CP is a fixed distance. So depending on this definition, we can easily find the equation of the circle. So let us come to that. Let us take this C as alpha beta, and this point P, since it is a moving point, so we are taking the point as x comma y. So what we are saying, that CP is a fixed distance. Let us consider this distance as A. So then what we can say, let us come here. CP is equals to A. Now C and P, these are two points in the two-dimensional plane, so we can easily find the distance between them. So what we can say for the distance? We can say that this distance CP is root over of x minus alpha whole square plus y minus beta whole square, and this is equal to A. And if you see carefully, by taking square in both sides, we can say that it is x minus alpha whole square plus y minus beta whole square is equal to A square. So this relation between x and y represents all the points on the circle. You take anywhere, any point, say this is x1 and y1. So you will see that these 2 points are also satisfying that relation. X minus alpha whole square plus y minus beta whole square is equal to A square. So in this case, this point C, you can say that this relation is the equation of a circle. This is the equation of a circle, and moreover, what you can say, that the point C is the center of the circle, and the point this point, this length A is the radius of the circle. These two things also we can say. C is the center, I think it should be center, and A is the radius of the circle. So if the equation of the circle is in this form, then we can easily find the center and the radius of the circle. This form has a name, it's called the central form. Central form. Okay, this form is called the central form. Now you see in particular, if I choose the center, C as the origin, what we will get for the equation? We'll get x minus 0 whole square plus y minus 0 whole square is equal to A square. So that we can write as x square plus y square is equal to A square. So this form is called the standard form of a circle. standard form of a circle. Okay, two forms we have done, the central form and the standard form. So for the standard form, what we are saying, if the circle is having a radius a and the center is at the origin, then we can write the equation as x square plus y square is equal to a square. This is the standard form. Simple enough, no problem, I think.
No, sir.
So then we are coming to a little bit complicated form. Now what we are doing, we are taking the central form x minus a whole square plus y minus b whole square, x minus alpha whole square plus y minus beta whole square is equal to a square, and we are expanding the whole square. We are expanding the whole square now. So then what we can write? X square minus 2x alpha plus alpha square plus y square minus 2y beta plus beta square is equal to a square. This we can write. So if I write it a little bit properly, means we are writing all the 2-degree terms first, then all the 1-degree terms, and then the constant terms. So if I write it like that, we can write it like this: x square plus y square plus it's minus actually 2 alpha x minus 2 beta y plus alpha square plus beta square minus a square. See, these are all the 2-degree terms. These are all the 1-degree terms. And these are, you can say, it is the 0-degree terms, because 0-degree means it is a constant. So these are, you can say, the constant terms. Okay. Now here, what it is actually, it's called the second-degree general expression. So let us write the second-degree general expression first, then we are coming to this equation. So general equation of second degree. That means we will write the general expression of second degree using two variables. So what will be the expressions? There will be 2-degree terms like ax square. With each term there will be a constant in general. So ax square plus 2hxy. This is also a second-degree term because it's the product of x and y. Plus by square plus, so this is the second-degree part. Then it is coming as the first-degree expression like 2gx plus 2fy plus the constant term c. This is called the general equation of second degree. Now if I compare this with this, what we get? See, the coefficient of x square and coefficient of y square are 1, 1. Now here in general it is a and b. So if this, let me give an equation number here, say star. So if this star represents a circle, then what you will get? The coefficient of x square and the coefficient of y square, as here, it should be equal. So then we can write, then a is equal to b. And you see that here in this equation, there is no xy term. So what we can write? Since there is no xy term, that means in the general equation, the coefficient of xy must be 0. So we can write h is equal to 0. Okay. So if this is the condition, then what we are getting? We are getting something like this: x square plus y square plus 2gx plus 2Fy plus C is equal to 0. And if you compare this with this one, you can easily see it is of the same form, just the constants are different. Here it was minus alpha, here it is G. Here it was minus beta, here it is F. And here it is alpha square plus beta square minus A square, here it is C. So this is the only difference. So in general, we can say this is the equation of a circle. So this condition is very much important, that a general equation of second degree represent a circle if A is equal to B and H is equal to 0. And if this condition is imposed, what we are getting? We are getting the equation of the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0. This is called the general form of a circle. This is called the general form of a circle. Is it okay? Okay. So I think this side you have covered already. So I can erase this part. So now if I come to this, you see very carefully that comparing this one, this general form and this equation. So let me give some numbering here. This is say 1 and this general form is 2. So what we can say here is that comparing 1 and 2, what we are getting? Comparing these two, we can get that G is equal to minus alpha, F is equal to minus beta, and C is equal to alpha square plus beta square minus A square. Alpha square plus beta square minus A square. So what is the advantage here? Previously we have taken that alpha beta as the center and A as the radius. Okay, you need to join the meeting again. Let me say it previously. So alpha and beta are the center and A is the radius. So now we are trying to find those values from here. So from here we can say alpha is equal to minus G, beta is equal to minus F, and A square will be G square plus F square minus C. If you see carefully, for alpha we are putting this G, for beta we are putting F and changing the side. So from here we can say A is equal to root over of G square plus F square minus C. So what was the advantage from here? Previously we have seen that the center of the circle was alpha beta. What we are writing here as minus G minus F. And previously the radius was A. Now what we are writing as root over of G square plus F square minus C. So if we are having the equation of the circle in the general form, we don't need to convert it into the central form to calculate the center and radius. From this form itself, we can easily find the center and the radius of the circle. So if the equation of the circle we are taking like this in general form, x square plus y square plus 2gx plus 2fy plus c equal to 0, then we can say that the center of the circle will be minus g minus f, and the radius of the circle will be root over of g square plus f square minus c. This is very important because most of the times this will be the equation of the circle, and from this equation we have to calculate the center and the radius. So we are having a direct formula here. This is important. No issues, I think. No complications. So then we are coming to simple problems. You take the note first
Okay,
and then we'll come.
sir, taken.
Okay. So remember this form: x square plus y square plus 2gx plus 2fy plus c. So for MCQ, suppose I'm asking that x square plus y square, say lambda y square plus um, say 2x plus 6y plus 2 is equal to 0. This is second degree equation. So when it will represent, or if this represents a circle, okay, let me make it a little more complicated. So I'm taking 5 here. 5x square plus lambda y square plus 2x plus 6y plus 2 is equal to 0. This equation, if this represents a circle, then what is lambda? Then what is lambda? This is the condition. A is equal to B and H equal to 0. A and B means
The
these are the
lambda,
coefficients. Yes, Bala?
the lambda is constant.
Yes, obviously, lambda is a constant. So here in this condition, A was the coefficient of x square and B was the coefficient of y square. So from here what we can say? That A is equal to B is the condition. So must this lambda must be is equal to 5. A is equal to B. And the next question will be, what are the center and radius of this circle? What are the center and the radius of this circle? So to answer this, you need to write the general form first. So if you put the value of lambda in this, you are getting the general form as 5x square plus 5y square plus 2x plus 6y plus 2 is equal to 0. Now here you see we need this form x square plus y square, but here there is a 5. So we need to divide it with 5 so that this becomes x square plus y square. So dividing by 5 we can write x square plus y square plus 2x by 5 plus 6y by 5 plus 2 by 5. This is equal to 0. This is equal to 0. And then see this 2g, if you compare it with the general form, this 2g is the coefficient of x, that means it is 2 by 5, and 2f is the coefficient of y, so that is here 6 by 5. So from this two, you can calculate the value of g and f. You can calculate the value of g and f. So clearly, g is 1 by 5 here and f is 3 by 5 here. So what we can say from this one, that the center is minus 1 by 5 and minus 3 by 5. This is clear? Very easy. And then you need to calculate that quantity here as, okay, let me just change this equation a little bit. This should be minus 2. Otherwise it will not work. We are taking it minus 2. You will see, you will understand why. So if I calculate the radius, we can write it as root over of g square plus h square minus c. So you see 1 by 25 plus 9 by 25 minus c is minus 2 here. See, the constant term is minus 2. So minus of minus 2. That means if I calculate it here, it's plus 2, so 50. 50 plus 10, so it is root over of 60 by 25. And how much it is? We can write it as 60 by root 60 by 5 only. So this will be the radius of the circle. Is it okay?
Yes, sir.
So this is the way that from the general equation we can find the center and the radius of the circle easily. Okay, so this much is very clear, I think. No doubts are here.
No, sir.
Okay. In the next class, we will be doing the condition for tangency. And some more topics are there. That is the length of a chord. That means if I take a circle like this, and if one straight line intersects it like this, then this section, this line segment here, inside the circle is called a chord. And if some line touches the circle in a single point like this, then those lines are called tangents to a circle. Okay, this is chord which is intersecting the line, and this is a tangent which is touching the line. So there is a difference between these two. So we need to study the chords and the tangents of a circle. These two topics are left. This we will do in the next class.